Hi, everybody. As Michael said, my name is Ivan Pavić. I work at King ICT as a software architect. And today I'm going to talk about anemic domain models. Why? Because I think that it's a very common problem. I've seen it in many projects during my career. And today we'll talk about it from the perspective of a Lollywood public transportation system. It's a city integrated transportation system, which mainly is a typical one. It has only two parts. It has one part where normal people live, and the other part where the desperados live. But we'll come to that a little bit later. The main thing we're building, because we work the agile, we have our initial backlog. We have to show to the clients, to our customers, the client information, and to offer to the customer, to the client, their coupons. Coupons are something that you use to validate yourself in the public transportation vehicles. So after the initial business analysis, we found this model. We have multiple clients that have multiple profiles. Every client must have at least one profile. Every profile has a number of tariffs, depending on if it's a day, month, or a year tariff. For example, if you can have tariff for 1 month or 1 year or for even 1 day. The main thing and all the business logic will be here. We have to calculate these coupons dynamically, depending on the day of month when the customer arrives and depending on the tariff period. For example, if it's a 6th month, if your client comes during the 6th month, you will offer him a coupon for 6th month or for 7th month. You won't offer him a coupon for a 3rd month, for example. So, after this initial business analysis, we create some solution architecture. Of course, today we have multi-layered software architecture, where we have service-oriented architecture, we have a model, we have a repository, we have the database behind to store all the data. So, but of course, we have some kind of cross-cutting layer in form of infrastructure project. This infrastructure project provides us with the caching, helpers, configuration, logging, and so on. Even that infrastructure project contains base classes for numerous design patterns like inversion of control containers, layer supratype, unit of work, strategies, and so on, and domain event handlers, and so on. In the end, we came up with this kind of solution. Of course, this is a simplified version of one real project, real-life project. We have services that coordinate success, that uses the model to store data in some kind of repository. In the meantime, we have to do some kind of business logic. Okay, so what does the domain model look like? We have the client class, as I said earlier, which has profiles. Profile class looks something like this. Of course, this profile class has available tariffs and available coupons. These are the coupons that we have to offer to the client. Tariff looks a bit like this, and the main thing, this coupon has valid from, valid to, tariff inside of it, and the main thing is the price. As you can see, these all classes are called, I don't know, POCOs, dehydrated classes, and so on. They have public getters, public setters, and they contain no logic at all. So, where do we put our business logic? The business logic usually goes in the services class. Service class contains everything that needs to be done with this client. We have the client service class, and we have the main method is get the client. If we get the client, we get his info, and we get all of his tariffs and all of the available coupons that he could buy. Mainly the business logic is in this line. If we look at it in more detailed view, we will see it consists of three methods. One for generating coupons for client, where we have to for each profile and generate coupons for each of that profile. As you can see, we are constantly checking if this is null, or anything else is null or has something in it. The other method is to generate coupons from tariff. We have here a recursive function to create coupons, and we have a hidden method within this region to calculate the prices. It looks a bit like this. In the end, when we look at it, the result is dehydrated business model, service that drives the business logic, and the 310 lines of code. No big deal. It's a clean solution. Everything works fine. Everything is great. And then the new user stories came. New users stories, they wanted some kind of shift reports for their employees. They want to issue invoice for the coupons, to fiscalize the invoices and so on. And they want to save these coupons to smart cards. Okay, we implemented that. We won't go into details with that. And we added two new classes, two new service methods, and roughly it's after that about 445 lines of code. And then it came, the sale network expansion. They wanted to expand their network, not only to their own sale network, but to kiosks, to newsstands and so on. But only the few tariffs will go through these kiosks. So, how do we implement this? We had a new property, of course, with public getters and setters in the tariff class, and we come up with a new service that is now called the kiosk service. Mainly, these two services are more or less the same. What are the differences? Kiosk service doesn't have shift, it doesn't have invoice. But because we don't have any logic in our classes, the business logic to generate the coupons must be somewhere. So we, of course, as in the first example, we implemented it in a service class. The only difference is this one line of code, depending on the property of the tariff class, if it's available for sale kiosk or not. So, and after that, the desperados are coming. These are the guys from the beginning of the story. And they have a local sheriff who is offering them a discount, to pay for discount so they could buy cheaper tickets. Why? Because they can. They have their own sale network and so on. When everybody else heard of it, they wanted the discount too. So we had to implement a discount for desperados and for not desperados. But these clients, in the main client service, we have to be careful to not to offer two discounts. The client can have only one discount. So after we implemented all of that, the final result is that we have another service called the Desperado service. It's mainly the same as the kiosk service and the client service, and the only change is in that one method that calculates the prices. We have to apply our discounts somewhere, and the best place is, of course, the place where we calculate the prices for the coupons. Yes, we had to change the model, of course. So we added this new property and this discount property to the tariff object. in the end, we still have a pretty much solid solution. Separations of concerns are taken care of. We have all the logic is separated in different services. We have still a clean model. We have only 1,303 lines of code altogether. But what are the problems with this approach? If you look at the solution, we will find that we duplicated more than 80% of the code. Yeah, mainly the business logic is in this 80% of code. We have a scattered business logic and we have a decaying model. Why is the model decaying? Because in the meantime, all the developers quit their job and went to Dublin. So we had to hire new guys. And this guy came to this model and asked and is asking a question. Why is this here? You don't do anything with this discount. Who can change this property? Under which condition could it be changed? What does this client do? What can he do? What can he not do? Why is he even here? Why is this Desperado property? What does it mean? Well, why is he wondering that? Because what's the problem? If you go to the basic of the object-oriented programming, you'll find that the objects, EA classes, are abstraction of the real-life objects. So, and the real-life projects have properties, have events, and have methods. Our classes Poco classes that we created down there, had only properties. They didn't have any behavior at all. So that's the problem. If we look at our solution in a bird's eye view, we'll find that we have a client service, that we have a kiosk service and Desperado service, all throwing around and managing this little client. This little client doesn't do anything at all. It's just property bags that are pushed around whenever and however they all want. And there is no one coordinating this. This service thing, I mean, this anemic domain model is an old problem. The only thing that changed in the past 5 years is this service part. Before that, they were called the client manager, high kiosk manager, and Desperado manager. But the logic is still the same, and the way of thinking is still the same. So if we use that OOP paradigm to abstract the real objects to a conceptual model, and we reverse that model, this is what we exactly did. We have 3 managers that is coordinating this little plonker here, Rodney. So, what is the solution to this problem? Of course, if you ask the managers, the probable solution would be that we introduce another manager, coordinating manager, to coordinate the managers. Now, really, the solution is to make Rodney a Rodney Balboa, meaning that you have to build him some kind of character. You have to encapsulate the logic inside of him. You have to put the things where they belong. If client can do something, that logic should be in the client. You have to be precise in telling, in naming the methods and everything to express what he can do or what he can't do. For example, it's like writing a good CV. With a good CV, you are telling people what you can do and what you can't do. And you are putting in charge of your career. You have to hide the implementation inside the model. Of course. Why? Because then you have the edge. In that way, they cannot tell you how to do it. You are controlling your own destiny. You have to inject dependencies and treat services as waiters. Services are the ones that should be dehydrated from any business logic. They are all just the waiters to provide you all the data that you need for your classes to do their thing. if we look at the refactored version of this code, it would look something like this. We have this class profile. We'll have few comments on it. First thing first, make your setters private. Let the class decide when and how it changes its properties. Of course, and when. Constructors, if you all know that in object-oriented programming, the constructors are the main thing, how to control the behavior of an object. But beware of the constructors because they don't solve everything. I mean, if you use some kind of serializer, or if you use some kind of automapper or something like this, constructor will be overridden in that case. So we'll have to build another method to compensate that. Another thing, be explicit in naming. This method shows exactly what it's doing, but not how it's doing. Another thing is to inject dependencies. And dependencies should be injected via services. Service will bring that to you. Use service, that's exactly the point of application service, to provide the business classes and domain model with the dependency it needs to calculate or do the whole business logic. Let the model validate itself. Don't validate it outside the model to check constantly if it's null, if it count is greater than null, if it exists, and so on. Model can validate itself in this case. If we look at another class, it's coupon, we'll see that I've changed a little bit about this discount. First thing, depend on abstractions, not the precise implementations. If you have some kind of interface, use it. And another thing, every problem has been solved before. So you probably have some kind of design pattern or find solution for your problem out there that you know it will work and it will be maintainable. Aftermath of this whole refactoring, we reduced the lines of code by more than 50%. We have no code clones, and after all, we have a more maintainable solution. Because it's readable, everybody can skip in and understand what the model is doing and why it's doing its job. So, that's all for me. Do you have questions, Heidi? No? Okay. Then thank you. And Rodney, thanks also.
We have a few minutes for questions, so if you have questions, fire them out.
Anyone? No?
Any provocations?
Objections? Yes?
Hello. At what percentage of projects this way of thinking should be used?
You mean the scale
For
of the project?
for business applications. Is it doable for most of the projects, or?
Yes, I think it's doable for the most of the projects. If you Google and search for it, they will say it's for the enterprise level applications, it's for the complex business logics and so on. But really, in my opinion, there is absolutely no reason to use the weak model, anemic domain model. It only looks that you're going faster at the beginning, but in the end you will have more problems.
Okay, one more question. Why didn't you, for example, use extending one common class and reuse methods in kiosk servers or other classes?
Because of
that would also reduce
yes,
lines
it
of
could be solved that way. This is one way of dealing with the problems. We could, of course, chain the services together, one service calling in the other service. But in the end, you will have, if the business logic expands, you will have lots of services cross-referencing each other, always calling one each other, and you will probably have a lot of problem of catching the information, who is calling who and when. the problem stays the same, just that you manage it differently. So,
Thank you.
okay. Anyone else? In mostly the structure map. Structure map, mostly. Excuse me. Why? I don't know. It's faster than Ninject. Is the first one I used. We get used to it, and that's why we're using it. And it's in our radar. So that's the cause.
I don't think the model you are proposing, but I don't think I fully understand it. So you basically just some kind of expansion of a regular object-oriented model. Is
Okay.
You when we on college when we started learning object-oriented,
Yes.
we created the class and added the properties, methods, and properties.
You
and
mean
methods.
the properties are contained from public properties and private fields? You mean that?
Yes, that classic, and so it basically just expansion of that with
Public get and public set.
and with service. That's
Yes.
with expansion of that with services that connect that work together.
Yes.
Okay. Just want to. It wasn't clear, so just wanted to clarify.
Okay. Problem. Anyone else?
One last question.
Yeah. There.
Okay. What happens when your model object needs another model object, which is generally the case? Many calculations involve many model objects at once. It's not so cleanly separated. Many operations are not property of just one model object. So how do you solve this problem?
Yes, it's a complex answer. Mainly, if you look at some of the approaches that exist in domain-driven design, the way to solve this problem is through aggregate roots and aggregates, where you should have one cluster of objects that have only one entry point. And if you have to coordinate that logic with another cluster of objects, the logic should be involved on these aggregate root objects and only on them. It's a tricky question. It involves a lot of experience how to manage and how to group those objects together. But yes, that is one of the problems of rich domain models. But I think it's a fair trade-off. It could be managed more easily than with another objects that is managing other objects. If you look at it from a perspective of a person, everyone should be in charge of their own destiny, and how they do it, and which condition, and they determine how they coordinate with each other. One of the solutions for this problem could be using domain events. For example, when something happens here, then something is triggered inside of another cluster or inside of another aggregate, for example.